Hello guys, my name is Venkat Sai. I am studying in Sri Venkateshwar College of the Engineering. Today we are discussing about data processing and instructions. In this context going to be discussed what is data processing instructions, what are the types of data processing instructions, what is barrel shifter, some examples for data processing instructions. Data processing instructions. These are the fundamental arithmetical and logical operations of the processor and operates and value in general process registers or a register and an intermediate value. Multiply and divide instructions can be considered special case for this instruction. We use data processing instructions to manipulate data within the registers. Types of data processing instructions are arithmetic instruction, logical instruction, multiply instruction, comparison instruction, move instructions. Most of data processing instructions use a barrel shifter to pre-process the data of one of their operand. Each operand updates different flags in the CPSR. Arithmetic instructions. Let us discuss the instructions in detail. Arithmetic instructions. The arithmetic instructions mainly implement addition and subtraction of 32 signed and unsigned values. And syntax we use for arithmetic instructions. And some operations in arithmetic instructions are ADC, add with 32-bit value, and carry. ADD, add two 32-bit values. RSB, reverse subtract of two 32-bit values. RSC, reverse subtract with carry of two 32-bit values. SBC, subtract with carry of two 32-bit values. SUB, subtract two 32-bit values. And we are going to logical instructions. Logical instructions perform bitwise logical operations on the two source registers. And syntax. Logical instructions operations are AND, logical bitwise AND of two 32-bit values, OR logical bitwise OR of two 32-bit values, EOR logical exclusion OR of two 32-bit values, BIC logical bit clear and NOR. And multiple instructions. Multiple instructions multiply the contents of the pair of registers depends upon the instructions and accumulate the result along with another register. The long multiply accumulate onto a pair of register represent a 64-bit value. The finally result is placed on a destination register or pair of register. Syntax. MLA multiply and accumulate. MUL multiply. And operations are SMLAL signed multiply accumulated long. SMULL signed multiply long. UMLAL signed unsigned multiply accumulated long. UMULL unsigned multiply long. Comparison instructions. These instructions are used to compare or test a register with 32-bit value. They update the CPSR flag bit according to the result, but do not affect other registers. After the bit have been set, the information can be used to change program flow by using conditional execution. And operations are CMN compare negated, CMP compare TEQ test for quality of two 32-bit values, TST test bit of 32-bit value. Move instructions. Move is the simplest ARM instruction. It copies n into n destination register RD, where n is a register or intermediate value. This instruction is useful for setting initial values and transferring data between registers. Operations are move. Move a 32-bit value into a register. MVN. Move the not of the 32-bit value into a register. Arithmetic and logical operations. Types arithmetic add, sub, ADC, SBC, NEG. And logical and BIC, ORR, ORN, EOR, EON. And comparison CMP, CMN, TST. And move MOV, MVN. And barrel shifter. It is a device to shift a word with variable amount. It is one of the logical device used to pre-process one of the operand register before operating onto the ALU operations. And it is one of the best feature of ARM. Most data processing instructions can process one of their operand using the barrel shifter. Mnemonics. In mnemonics, LSR stands for logic shift left, LSR stands for logic shift right, ASR stands for arithmetic right shift, ROR stands for rotate right, RRX stands for rotate right extend. Here X represents a register being shifted and Y represents a shift amount. Examples. The simple subtract instruction subtract a value stored in register R2 from the value stored in register R1. The result is stored in register RO. And R0, 0 into 8 zeros. As this register is a register to hold the output, that's why it is empty before execution. And R1, R1 is equal to 0 into 7 zeros into 2, because register R1 holds the value 2. And R2, 0 into 7 zeros and 1, because R2 holds another value 1. When we sub R0, R1 and R2, R0 is equal to R1 minus R2. Here the subtracted value R0 minus R1 is moved to the RO after performing operations. Post R0 is equal to 0 into 7 zeros into 1. This is the output of above instructions moved to the RO register. And second example is, this example shows a logic OR operation between register R1 and R2. R0 holds the result. R0 is equal to 0 into 32-bit value. R1 is equal to 0 into 020406008. R2 is equal to 0 into 10305070. And the logical operator is ORR, RO, R1 and R2. R0 is equal to 0 into 12345678. The another example is, this example represents the simple multiply instructions that multiply register R1 and R2 together and places the result into the register R0. Register R1 is equal to the value 2 and R2 is equal to 2. Then replace to R0. R0 is equal to 0 into 32-bit value register to hold the output. R1 is equal to 0 into 7 zeros into 2. Register holds the operand 1 value. And R2 is equal to 0 into 7 zeros into 2. Register holds the operand second value. And we are using multiply operator R0 and R1 and R2. R0 is equal to R1 into R2. R0 is equal to 0 into 7 zeros into 4. Output of the multiplication operator. R1 is equal to 0 into 7 zeros into 2. R2 is equal to 0 into 7 zeros into 2. Operands. In this video, we learn about what is data processing instructions, types of data processing instructions, what is barrel shifter, examples for different types of instructions. Thank you.